Hello, welcome to Apollo Task 1 using a quadratic graph to find the equation. Here we've got a sketch of the quadratic graph. We don't have any indication of where it goes through the y-axis. We just have, it's got its minimum point at 3, 4. And we've also got another coordinate, 1, 12. So we're told this information in the question, a graph. The graph shown is of a quadratic function. Its turning point is A, which is 3, 4. The curve also passes through the set of coordinates B, 1, 12. First, I want you to try and think about how we find the equation of the function in the form ax squared plus bx plus c. I'm going to go through that, but might be an idea if you pause it and have a go. Okay, let's try this then. Now, with a lot of maths problems, there's a lot of different approaches. I'm just going to show you one. Now, because I know the minimum point, I can actually use the completed square form. Now, I know the minimum x coordinate, at the minimum point, the x coordinate is 3, so I'm going to say x minus 3 squared plus 4. So I know that I can write it in that form. Y equals a lots of x minus 3 squared plus 4. But I also know I've got the coordinates 1, 12. So I can substitute that in. Feel free to pause and have a go at that yourself. Okay, let's see what happens. So 12 equals a lots of 1 minus 3 squared plus 4. 12 equals 1 minus 3 is negative 2. Negative 2 squared is 4. So I've got 4a plus 4. So 4a plus 4 is 12. 4a would of course equal 8 and a equals 2. So I know my equation is y equals 2 lots of x minus 3 squared plus 4. So I just move that up. Right, now we've got to be careful here because remember the question. In the form ax squared plus bx plus c. Let's just move that closer so we can see this a little bit more carefully. So y equals 2 lots of x minus 3 squared. We're going to expand this. 2 lots of x squared. Hopefully you're confident with expanded brackets. Minus 6x plus 9 plus 4. Multiply by 2. And y equals 2x squared minus 12x plus 22, which is the answer we need. Well, that tells me another thing as well. That tells me my y-intercept. If you were asked about that, what's the y-intercept? Well, that is 0, 22. Now let's go back. We got to part 2. We've got to do a sketch of the reflected graph. Well, it's going to reflect in the y-axis, so let's put the new points. A prime would be negative 3, 4. There would be, it'd have to go through B, which would be minus 1, 12. Notice what happens here. Now I'm going to try to do my sketch as carefully as possible. Oop, I've gone wrong there. That's why you should use a pencil. And that is your reflected quadratic. Okay. Now what is the equation? Well, we know, hopefully we remember, that reflection in the y-axis is f of negative x. So, what can we do? Well, I could do this, is one way to do it. I know I'm going to replace from my answer to the previous part x with minus x. Two lots of negative x, squared minus 12 lots of negative x, not x, plus 22. So let's see what we get. Well, negative x squared is still x squared. Negative 12 lots of negative x is going to be plus 12. And we still get plus 22. So it should be negative 2x squared plus 12x plus 22. So we just replace x with negative x. We could show that another way as well. We could use the completed square form like we have done. Like we did in the previous question, there's always several ways to look at a maths problem. Okay, here's a second problem for you to look at. So this is another graph. It shows a quadratic function. Again, its turning point is 2, negative 5 down there, and it also goes through 522. I'm going to pause this and then put the answer on, and I want you to pause as well and have a go at the question. Okay, we're back. Let's have a look. Hopefully you got the idea here. So the first part, well, I've done it in both forms there, completed square form. 3x squared minus 12x plus 7. So you'd get your intercept there is 7. Hopefully you were able to follow that method. There's your reflection drawn. And notice the equation of reflection, we just go from f of x to f of negative x. So the idea of going from f of x to f of negative x, that will reflect in your y-axis. And that's x squared, so it still remains negative x all squared is the same as x squared. And negative 12x goes to positive 12x, and that has the effect to reflect it. Well, hopefully that Apollo problem was clear. That's a very useful skill, very good analysis of the link between the algebraic equation of the function and the graph. Thank you very much.